today we are going to wrap up section 1.5, and there's some other things that we didn't get to the other day. The other day we were doing all the naming, so today we're going to kind of put that into practice a little bit. So the first thing is to review a protractor, and essentially a protractor, do you love my design? Isn't it amazing? Is a tool that we use to measure angles. So I have one here that is, of course, just like the one that I drew. It's almost identical. It's crazy how good of an artist I am. But anyways, we're going to use this one, but I want to make sure I have some kind of a picture in my notes, right? So you have some kind of a picture so you remember what a protractor is, and then what it does. So for an example, I have angle BOC right here, knowing and remembering that this middle piece is that hinge or the vertex. And that's really important how it's named. If I say BOC, you know exactly what this angle looks like because I know that the O is here on the hinge. If I said something like OCB, I would know that the C would be here and the O and the B would be on the outside. So it really does make a difference where that vertex lies within that angle, okay? The next piece is knowing and understanding this idea of protractor. And in 1.3, we have a protractor postulate. So again, remember, a postulate is a rule that's already determined, and it's then stuff in math that we already know about. It establishes that rule, and we're going to use those later on in our proofs. And basically what our protractor postulate tells us is that those rays that create that angle can be matched up with numbers from 0 to 180. It's just saying that I can measure an angle. So if I go back and I decide that I have an angle that looks something like this, that I can use these two rays to line up the protractor, and I can match this one, let's say, to 0, and then I can match this one to, I'll call it 100. So I know that this angle measure is 100 degrees. So that's what the protractor allows us to do. The next piece, what we're going to do today, is practice more constructing. So you need your compass and straight edge. And remember, this is what a compass looks like. And a straight edge, we can, of course, just use a ruler, but it could just be any old straight edge, your notebook, piece of paper, whatever. We're going to create and draw an angle, and we'll just call this angle A. And what I want to be able to do today is copy this. Remember the last time we did a construction, we copied a line segment. Well, today we're going to copy an angle. So to copy this angle, I want to draw this exact same angle down here. How that happens is I draw another line segment, okay? I'm not measuring it, so I'm not actually like using the ruler itself. I'm just using it as a straight edge, okay? Now what's going to happen is I take my compass, and again, make sure it's kind of locked up here, that it's not super loosey-goosey, otherwise it's not going to work very well for us. And I'm going to take that pointy or sharp edge, and I'm going to put it right on the vertex, maybe. And then once I have this adjusted, I'm not going to touch it again. I'm going to do a nice little swing. I'm going to go all the way across the angle. And then I'm going to pick this up, and I'm not going to touch it. I don't want it to move at all. I'm just going to pick it up, and I'm going to move it right to that extra little line segment that I drew. And I'm going to do a swing, just like I did on the other one. Okay, so I did my original angle. I did a little swing. I picked it up. I put it on the edge, and I did another little swing. Now to measure how far and how much this angle opens or closes, I don't use a protractor, I still just use my compass. What I'm going to do is I'm going to take this compass and I'm going to place it on one of the little X marks the spots that I did my swing. And I'm going to adjust my compass so it matches that opening. And again, you can give it a little swing to make sure that you have that measured perfectly. And then again, don't touch it. I'm going to pick it up and I'm going to move it over here. And I'm going to do the same thing. I'm going to make sure it's right here where X marks the spot. And I'm going to give it a little swing So I see right here, this little X marks the spot. And now I can come back with my straight edge and I can mark it. And that is how you copy an angle. Our next postulate today is the angle addition postulate, and this is postulate 1.4, and it's kind of similar to the segment addition postulate that we did. Remember, in the segment addition postulate, we had a line segment, and we said that this one plus this one, these two little pieces, add to be the whole piece. What's really similar to this angle. So I have this whole big angle, this big angle ABC, and it's created taking this angle right here, this ABD, with this angle right here, DBC, and together it equals the whole thing. So these two little pieces add to be the whole big piece. So again, really similar to what we've done before, except instead of a segment, it's an angle. So let's get an example into our notes. And we can see here this whole angle measure of LKN, the whole measure is equal to 145. So think about what we just talked about. This angle here plus this angle here is going to equal the whole entire angle. So that little angle plus this other little angle equals the whole big angle. And remember, they gave us that the whole entire thing is 145 degrees. And this little piece plus this little piece is going to equal 145. So we have a little bit of algebra to do. In my algebra classes, when we combine, we go through and highlight. There's the bell. So I have 2x plus 4x. I'm going to combine those together and get 6x. Then for the numbers, I have 10 minus 3, which is 7. And now I can go through and solve this equation. So if you've had me before, we cover the variable to know what our first step is. And I'm going to ditch this 7. And in order to ditch it, I want to do the opposite. Since this said plus 7, I'm going to minus 7. So we have 6x equals, what is that, 138. And last step to get this x all alone, this says multiply by 6. So I want to divide by 6. And x would be equal to 23. Okay. And in this problem, they asked, let me double check what they asked for. They asked us to find what these two little angles are. So I know that x is 23, but that's not my answer. They're actually asking us to know what these angle measures are. So I've got to put 23 back into my answer up here. So I would do 2 times 23, and that would be 46, plus 10 would be 56 degrees. Then I would put 23 into here. 4 times 23 is 92, minus 3 is 89. I could double check my math real quick. These two little pieces should add to be 145. Now our last piece is one more construction. And the last construction is to take an angle and to bisect it. Okay, so with my straight edge, I am just going to create an angle, any kind of angle you want. I'm going to take my compass and I'm going to open it up a little bit. I don't want it to be too skinny, but I also don't want it to be like super huge. So I'm going to open it up a little bit. I'm going to put the sharp, pointy edge on the vertex, and I'm going to make an arc. Okay, and I should have made this a little longer. There we go. Extend those out just a little bit. Okay. Now I am going to take my compass and maybe make it just a tiny bit smaller. It doesn't have to be huge or super tiny. But what I'm going to do is both of these little spots here, like X marks the spot, I'm going to take my compass and I'm going to put it right in here. And then I'm just going to kind of swing and make a little arc somewhere out here. Doesn't have to be anything perfect. And then I'm going to pick it up and I'm going to take that same thing. Now don't move it. If I accidentally move it, I can start over again. X marks the spot and I'm going to do the same thing. Okay, so again, I'm going to pick my compass here. I'm going to dig it in, make a little arc, pick it up, don't move it, and then do it again. And this little dot right here will be the bisector. I am chopping it, whoops, terrible line there. I am chopping it right in half. So that is how we bisect an angle.